Welcome back. Let's try continue. I'm a little bit sleepy tonight because it's hot in my apartment. I don't think it's boring. It's 29. I don't think this PDF is boring, but I not understand much of this. So, but there's many pages left. It's 6 p.m. Let's try continue. Let's try finish what happened news in the Danish television. In like 35 minutes, got the news. I like to watch the news. Probably I have to stop the video again. But I'm start to upload the last 3 parts. Yes, because the Danish government have an important meeting today about how they like to spend the money next year. The next year in the parliament, I like to watch that. Yes, continue.
Activate the specified row. CMD4 equals 0 to use the currently open row. CMD3 equals 1 to transfer an 8-word burst. CMD3 equals 0 for a 4-word burst. CMD2 equals 1 for write. CMD2 equals 0 for read. CMD1 equals 1 to close the row after this access. CMD1 equals 0 to leave it open. CMD0 selects the DCLK pair to use, DCLK1 or DCLK0. A notable omission from the specification was per byte write enables. It was designed for systems with caches and DCC memory, which always write in multiples of a cache line. Additional commands, with CMD5 set, opened and closed rows without a data transfer. Performed refresh operations, read or wrote configuration registers, and performed other maintenance operations. Most of these commands supported an additional 4-bit sub-ID, sent as 5 bits, using the same multiple destination encoding as the primary ID, which could be used to distinguish devices that were assigned the same primary ID because they were connected in parallel and always read /written at the same time. There were a number of 8-bit control registers and 32-bit status registers to control various device timing parameters. Virtual channel memory, VCM, SDRAM. VCM was a proprietary type of SDRAM that was designed by NEC, but released as an open standard with no licensing fees. It is pin compatible with standard SDRAM, but the commands are different. The technology was a potential competitor of a DRAM because VCM was not nearly as expensive as a DRAM was. A virtual channel memory, VCM, module is mechanically and electrically compatible with standard SDRAM, so support for both depends only on the capabilities of the memory controller. In the late 1990s, a number of PC Northbridge chipsets, such as the popular VIA KX133 and KT133, included VSDRAM support. VCM inserts an SRAM cache of 16 channel buffers, each a quarter row segment in size, between DRAM banks sense amplifier rows and the data I/O pins. Prefetch and restore commands, unique to VSDRAM, copy data between VDRAM sense amplifier row and the channel buffers, while the equivalent of SDRAM's read and write commands specify a channel number to access. Reads and writes may thus be performed independent of the currently active state of the DRAM array, with the equivalent of 4 full DRAM rows being open for access at a time. This is an improvement over the 2 open rows possible in a standard 2-bank SDRAM. There is actually a 17th DUM ICANL used for some operations. To read from VSDRAM, after the active command, a prefetch command is required to copy data from the sense amplifier array to the channel SDRAM. This command specifies a bank, 2 bits of column address, to select the segment of the RAW, and 4 bits of channel number. Once this is performed, the DRAM array may be pre-charged while read commands to the channel buffer continue. To write, first the data is written to a channel buffer, typically previous initialized using a prefetch command, then a restore command, with the same parameters as the prefetch command, copies a segment of data from the channel to the sense amplifier array. Unlike a normal DRAM write, which must be performed to an active, open, row, the DRAM bank must be pre-charged, closed, when the restore command is issued. An active command immediately after the restore command specifies the DRAM row completes the write to the DRAM array. There is, in addition, a 17th dummy channel which allows writes to the currently open row. It may not be read from, but may be prefetched to, written to, and registered to the sense amplifier array. 36, 37, although normally a segment is restored to the same memory address as it was prefetched from, the channel buffers may also be used for very efficient copying or clearing of large, aligned memory blocks. The use of quarter-row segments is driven by the fact that DRAM cells are narrower than SRAM cells. The SRAM bits are designed to buffer DRAM bits wide, and are conveniently connected to one of the 4 DRAM bits they straddle. Additional commands prefetch a pair of segments to a pair of channels, and an optional command combines prefetch, read, and pre-charge to reduce the overhead of random reads. The above are the JEDEC standardized commands. Earlier chips did not support the dummy channel or pair prefetch and use a different encoding for pre-charge. A 13-bit address bus, as illustrated here, is suitable for a device up to 128-bit, 6. It has 2 banks, each containing 8,192 rows and 8,192 columns. Thus, row addresses are 13 bits, segment addresses are 2 bits, and 8 column address bits are required to select 1 byte from the 2048 bits, 256 bytes, in a segment. Synchronous graphics RAM, SGRAM. Synchronous graphics RAM, SGRAM, is a specialized form of SDRAM for graphics adapters. It is designed for graphics-related tasks such as texture memory and frame buffers, found on video cards. It adds functions such as bit masking, writing to a specified bit plane without affecting the others, and block write, filling a block of memory with a single color. Unlike GRAM and RAM, SGRAM is single-ported. However, it can open 2 memory pages at once, which simulates the dual-port nature of other video RAM technologies. The earliest known SGRAM memory are 8-bit, 6. Chips dating back to 1994, the Hitachi HM5283206, introduced in November 1994, 38, and the NEC PD481850, introduced in December 1994. 39. The earliest known commercial device to use SGRAM is Sony's PlayStation PS video game console, starting with the Japanese SCPH5000 model released in December 1995, using the NEC PD481850 chip. 40. 41. Graphics Double Data Rate SDRAM, GDDR SDRAM. Graphics Double Data Rate SDRAM, GDDR SDRAM, is a type of specialized DDR SDRAM designed to be used as main memory of graphics processing units, GPUs. GDDR SDRAM is distinct from commodity types of DRAM such as DDR3, although they share some core technologies. Their primary characteristics are higher clock frequencies for both the DRAM core and I/O interface, which provides greater memory bandwidth for GPUs. As of 2018, there are 6 successive generations of GDDR, GDDR2, GDDR3, GDDR4, GDDR5, and GDDR5X. GDDR6. GDDR was initially known as DDR SGRAM. It was commercially introduced as a 16-bit, 6, memory chip by Samsung Electronics in 1998. 8. High bandwidth memory, HBM. High bandwidth memory, HBM, is a high-performance RAM interface for 3D stacked DRAM from Samsung AMD and SK Hynix. It is designed to be used in conjunction with high-performance graphics accelerators and network devices. 42. The first HBM memory chip was produced by SK Hynix in 2013. 43. Timeline. SDRAM. Synchronous Dynamic Random Access Memory, SDRAM. Date of introduction. Chip name. Capacity, bits, 6. SDRAM. Type manufacturer, S. Process MOSFET area F1992 km 48 SL200016 Samsung, CMOS, 4. 3. 1996 MSM 5718 C 5018 Bitadramaki, CMOS 325mm 2, 44, N64 DRAM 36 bit RDIMNEC, CMOS, 45, 1024 bit Mitsubishi 150 NMC MOS, 46, 1997, 1024 bits Hyundai, SOI, 10, 1998 MD 576480264 Bitadramaki, CMOS 325mm 2, 44, March 1998 Direct RDIM 72 Bitadram Rambus, CMOS, 47, June 1998, 64-bit Samsung, CMOS, 8, 7, 9, 1998, 64-bit Hyundai, CMOS, 10, 128-bit Samsung, CMOS, 48, 7, 1999, 128-bit Samsung, CMOS, 7, 1024-bit Samsung 140 NMC MOS, 46, 2000 GSE DIM 32 Bitadram Sony, Toshiba 180 NMC MOS 279mm 2, 49, 2001, 288 Bitadram Hynix, CMOS, 50, DDR2 Samsung 100 NMC MOS, 9, 46, 2002, 256 bit Dynix, CMOS, 50, 2003 EE plus Xedram 32 Bitadram Sony, Toshiba 90 NMC MOS 86mm 2, 49, 72 bit DDR3 Samsung 90 NMC MOS, 51, 512 bit DDR2 Hynix, CMOS, 50, Elpida 110 NMC MOS, 52, 1024 bit DDR2 Hynix, CMOS, 50, 2004, 2048 bit DDR2 Samsung 80 NMC MOS, 53, 2005 EE plus Xedram 32 Bitadram Sony, Toshiba 65, NMC MOS 86mm 2, 54, Xenos DIM 18 byte DIM NEC 90 NMC MOS, 55, 512-bit DDR3 Samsung 80 NMC MOS, 9, 56, 2006, 1024-bit DDR2 Hynix 60 NMC MOS, 50, 2008. LPDDR2 Hynix, April 2008, 8192-bit DDR3 Samsung 50 NMC MOS, 57, 2008, 16384-bit DDR3 Samsung 50 NMC MOS, 2009. DDR3 Hynix 44 NMC MOS, 50. 2048-bit DDR3 Hynix 40 NM 2011, 16384-bit DDR3 Hynix 40 NMC MOS, 43, 2048-bit DDR4 Hynix 30 NMC MOS, 43, 2013. LPDDR4 Samsung 20 NMC MOS, 43, 2014. 8192 bit LPDDR4 Samsung 20 nm CMOS 58. (2015) 12-bit LPDDR4 Samsung 20 nm CMOS 48. 2018 8192 bit LPDDR5 Samsung 10 FinFET 59. 128-bit DDR4 Samsung 10 FinFET 60. SGRAM and HBM. Synchronous Graphics Random Access Memory, SGRAM, and High Bandwidth Memory, HBM. Date of introduction. Chip name capacity, bits, 6. STRAMP type manufacturer, S. Process MOSFET area F November 1994 HM528320068 MBIT SGIM, SDR, Hitachi 350 nm CMOS 58mm 2, 38, 61. December 1994 PD48185008 MBIT SGIM, SDR, NEC, CMOS 280mm 2, 39, 41. 1997 PD4811650016 MBIT SGIM, SDR, NEC 350 nm CMOS 280mm 2, 62, 63, September 1998, 16-bit SGIM, GDDR, Samsung, CMOS, 8, 1999 km 4132 G11232-bit SGIM, SDR, Samsung, CMOS, 64, 2002, 128-bit SGIM, GDDR2, Samsung, CMOS, 65, 2003, 256-bit SGIM, GDDR2, Samsung, CMOS, 65, SGRAM, GDDR3, March 2005 K4D553238 F256 MBIT SGIM, GDDR, Samsung, CMOS 77mm 2, 66, October 2005, 256 MBIT SGIM, GDDR4, Samsung, CMOS, 67, 2005, 512-bit SGIM, GDDR4, Hynix, CMOS, 50, 2007, 1024-bit SGIM, GDDR5, Hynix 60nm 2009, 2048-bit SGIM, GDDR5, Hynix 40nm 2010K4W1G1646G1024-bit SGIM, GDDR3, Samsung, CMOS 100mm 2, 68, 2012, 4096-bit SGIM, GDDR3, SK Hynix, CMOS, 43, 2013. HBM March 2016 Mount 58K256M32J8-bit SGIM, GDDR5X, Micron 20 nm CMOS 140mm 2, 69, June 2016, 32-bit HBM2 Samsung 20 nm CMOS, 70, 71, 2017, 64-bit HBM2 Samsung 20 nm CMOS, 70, January 2018 K4ZAF325BM16-bit SGIM, GDDR6, Samsung 10 FinFET 225mm 2, 72, 73, 74. See also GDDR, Graphics DDR, and its subtypes GDDR2, GDDR3, GDDR4, and GDDR5. List of device bandwidths. Serial presence detect, EEPROM with time.
Yes, the video splits in 30 minutes. We can just stop it. Last edit long time ago, many months ago. Yes, the video splits in a few seconds. So let's close this and just read the next one is DDR.